Hi everyone, my name is Yahui, and for my final project, I choose to study on optimizing performance and security in Intel SGX applications through multi-threading and switchless calls. Here is my presentation outlines. First, we are going to go over some background information, including software privilege level, trusted execution environment, and its evolution. Then we're going to deep dive into some SGX concepts, including enclave page cache, and enclave page cache table. Also, we're going to go over some concepts including thread control structures and multi-threading concurrency in SGX. Then we're going to move on to my project demonstration. We are going to go over some problem statements and my setup environment. Also, we're going to show the architecture design of the project and a demo. Then we're going to evaluate my project and do a security analysis of my project. To start with, software privilege levels restrict the access control. System management mode is a highly privileged execution mode used for hardware and power management. It provides low levels control for BIOS or firmware to manage system hardware, isolated from other execution modes to maintain system security and stability. VMX root is a privileged mode of operation for hypervisors in Intel virtualization technology. It provides hypervisor direct access to manage and control virtual machines. VMX non-root mode is less privileged mode for guest operating system running in virtual machines, which isolated from the hypervisor. It only has restricted access to hardware and relies on hypervisor, sometimes for certain operations. The traditional x86 architecture uses protection ring, which is a hierarchical protection domains to provide different levels of access to resources. Ring 0 here is the most privileged level, and it is used by kernel mode of operating system. It has full access to hardware and system resources. Ring 3 is the least privileged level and has limited access. It is often used by user mode applications. It relies on system calls to request privileged operations. Our SGX enclave lays in this category. Ring 1 and Ring 2 is rarely used and is often reserved for special purpose like device drivers. Trusted execution environment is defined as a tamper-resistant processing environment that runs on a separation kernel. It guarantees the authenticity of the executed code, the integrity of runtime states, and the code confidentiality. It has four main secure prerequisites. First is data separation. Data within one partition cannot be read or modified by other partitions. Also, it has sanitization. Its shared resources cannot be